Right, okay guys, quickly we have this time. There is too few questions from level 3 and level 5. So you need to have an idea about how to do these kind of questions. Okay? So we'll do this first, specifically first for advanced part we'll do one or two questions. One multiple correct option type questions, another level 3 questions. So then there was the level 3 questions. Then you can go ahead with level 2. What you call simple pendulum energy questions also. Right. So now, listen the question. I think in the neat volume this question will not be there. It is only available in neat volume. Just listen the question and you can follow the diagram. Now, the rest you can go to the volume and share with others if you have more than 2 volumes. The question is, two blocks A and B, each of mass m, are connected by a massless spring of natural length L and spring constant K. The blocks are initially resting on a smooth horizontal floor with the spring at its natural length as shown. I will show you the figure diagram. The third identical block C, also of mass m, moves on the floor with the speed v along the line joining B and A and collides with B elastically. Then, which of the following options are correct? These are common type questions. So more than one option should be correct in this kind of cases. 29. So level 5. Okay. So what is this? First let us see the diagram. There is given that there is a horizontal surface. On this there are two blocks, block A and block B are connected by using a spring. Using a spring or spring constant K, and its natural length is L. When resting, when the natural length, this length, natural length of the spring is L. Natural length or original length is L. Now another block, identical block C, means having same mass. All are having masses, you can say M. These are having mass M, these are having mass M, these are also having mass M. Identical same mass. Identical velocity V, moving with velocity V, and moves on the floor with the speed v along the line joining A and B and collides with the B elastically. We have to underline this point. Elastic collision it takes place. So here we have to apply the concept of collisions also. You should remember the conditions of collisions. So what is the condition of elastic collision, or by the definition of elastic collision? A collision in which, for which both momentum and kinetic energy should be conserved. Such kind of collision will be called as elastic collision. Right? Perfectly elastic collision. Simply you can say elastic collision. The elastic collision is the collision in which only momentum conserves but not energy. So in this case what happens is, if this collides with this, so because initially both are at rest, this after collision, this block will move forward. As a result of spring will compresses. Till particular state A will not move. Once the spring compresses completely, then this edge of this will moves or presses A also, so that then A also starts moving, because the surface is a smooth surface. No energy loss will take, no momentum loss takes place. So whatever the momentum this is giving, this will be transferred to this, and it will move with the same momentum as that of the initial case. So you can say before collision and after collision. So this is the first particle, and these two are the other particles. So before collision and after collision, if you observe, you can say before collision this is moving, those two are at rest. Three particles if you consider 1, 2, 3. So from log, total initial momentum is equal to total final momentum. Before collision, it is moving with velocity gives what? Its momentum. So potential energy is 0, kinetic energy is half mv square. So you can take this as kinetic energy equal to kinetic energy, or you have to take it as initial energy is equal to final energy you have to take. Because here we come across potential energy for the spring mass system. So initial energy is kinetic energy half m v square is equal to before collision. Both of those are at rest, so no energy for them. Only this is having energy. After collision, this will stop, so it is not having any energy. Those will have energies of what? Half m v dash square plus what that it is half m v dash square plus this is spring. When it compresses, so maximum elongation if it happens in the spring constant. The maximum compression, there are so in the options, if you observe what kind of options are correct. So if you observe here, maximum compression you can calculate. So it is can also express this as by substituting v dash value m v square is equal to m v dash square plus m v dash square is 2 m v dash square. 2 m v dash is v by 2. So v by 2 whole square plus k x square. So here v, so here it becomes by 2 m square by 2. We said here it becomes k x square is equal to m square minus half m square is half m v square. Is it clear? Yes. Now, if you are supposed to find the maximum compression, you can find that x square is equal to m v square by 2k. 2k comes here. So is x square maximum compression from this is x is equal to square root of mv square by 2k. So this is one of the parameters you can understand from this. So that is required in the other. So maximum compression. The options if you observe, first option says frequency of oscillation of the system is how much. To understand, let us see how to make it work it out. Then if you know k, then you can get it. From this one you can get it. And the kinetic energy of the system at maximum compression of the spring is mv square by 4. Is it correct or not? Let us check. The maximum compression of the spring, it is mv square by, we got mv square by 2k. So v square, if we take it out, we can write it as v into root m by 2k. So in the options it is given as by taking v out, it is mentioned. So you can also write this as v into square root of m by 2k. Yes, this is there in the one of the options. It is correct. So that option is correct. Which is that option? Option D is correct. So option C is wrong. Then out of the first and second options, which is correct? Cross check. Kinetic energy of the system at maximum compression. What is the kinetic energy of the system at maximum compression? Kinetic energy of the system is when maximum compression takes place, A and B moves with the common velocity. Yes or no? That is v dash square. V dash square is equal to half into both will move common velocity. So half m into v dash square. But v dash is how much? V by 2. If you take this, what will you get? Half m into v dash is how much? V by 2. So wait, not half m v dash square. Half m v square, half m v dash square plus. So after maximum compression, what is kinetic energy of the system? This is potential energy of the spring. Kinetic energy of the system is half m v dash square plus half m v dash square. So you have to take this as plus half m v dash square is m v dash square. So it is equal to m into v dash is v by 2. So whole square is v square by 4. This is the kinetic energy at maximum compression. M v square by 4. So kinetic energy of the system at maximum compression is m v square by 4. Is it right? Yes. So you can understand. Yes. Then so fourth option is right. Third option is wrong. Second option is also correct. What about first option? Frequency of oscillation of the system AB When it is hitting this, it is compressed maximum and it is moving forward. It is not undergoing any oscillations, right? So if it is undergoing oscillations, you can think about the frequency. Here, no SHM is happening. Got it? So you cannot consider first option also. So option B and D are correct. So likewise, you can think about in case of multiple correct option type questions, how to choose the questions. So depending on the options, you have to check based on the options, you have to work out the parameters for the given system. From the given system, you have to derive the conditions, derive the answers. Okay. So this is how we can work out with the multiple option kind of questions. Next one, let us see. Level 3. Few more similar kind of questions are given here. So you can see in level 5 only, question number 4, similar kind of one. 5 also is similar kind of one. You can just go through this also. Similar kind of questions. Let us see now the questions in level 3 here. These are previous year's questions. Very important ones. Let us see, this method of questions are important. So let us see this. These are previous year's questions. Let's copy it. Yes, guys. Right. Sorry for the disturbance. Yeah, right. So let me read the question completely so that you can understand the scenario and you can follow. So a small block is connected to one end of a massless spring of unstretched length 4.9 meters. And the other end of the spring is fixed here, left side. The system lies on a horizontal frictionless surface. The block is stretched slightly by 0.2 meters, so that will act as amplitude resonance. 0.2 meters and released from rest at time t equal to 0. If it then executes simple harmonic motion with a block at t equal to 1 second. That means if it comes here and hits this somewhere here at time t equal to 1 second. At t equal to 1 second somewhere, the value of B is how much? What is the value? So that of B, so that after 1 second it is reaching somewhere here. To understand this, you have to just follow a few points here that at time t equal to 0 it is released. After 1 second where it will be. That is the point you have to consider. So it is released from here at t equal to 0 or 0.2 meters distance from here. After 1 second it is hitting, this means it may move somewhere here, so it will be somewhere here, so it is coming and hitting here. So what is the distance moved? As we are releasing the block from extreme position, displacement of a particle undergoes SHM. Displacement of a particle in SHM starting from extreme position is given by x is equal to a cos omega t. If it is starting from mean position, a sin omega t, right? So it is a cos omega t. It is mentioned that the display, we are asked to find what is the at time t equal to 1 second is hitting, when it is starting its motion with an amplitude of 0.2 seconds, we have to find what is the displacement. So x is equal to, as the amplitude is how much? 0.2 meters cos omega. Omega is how much? Pi by 3. At t equal to 1 second we want to know. So it is pi by 3 into 1 is pi by 3. Pi by 3 is how many degrees? 60 degrees. Pi by 3 radians is 60 degrees. Cos 60 is how much? 1 by 2. So 0.2 into 1 by 3 is how much? 0.1. 0.1 x is equal to 0.1 meters. So that means after 1 second, if you release at 0.2 meters at time t equal to 0, after 1 second it will be at 0.1 meter. Here it will be at 0.1 meter. Is it clear now? Yes. So it is hitting here means where will be the block from here? Actual length is 4.9. So that at time t equal to 1 second it will be at 5 meters. So the total length is 10 meters. It is 5 meters. The remaining distance will be 5 meters. That means it is hitting here means it is a projectile. Its range can be taken as 5 meters. Its range can be taken as 5 meters. As here you can take it as range of projectile is 5 meters. So you have to apply the concept of projectile motion here. So from the projectile motion concept, you know the range of projectile is what? So range is what? R. R is equal to U square. Here U is given as V. So V square sin 2 theta by G. Theta is how much? 45. 2 theta 90. So 91. So it is equal to, you can say, or this implies 5 is equal to V square. The sin 90 is 1 by G if you take less than, then you make it right. V square is equal to 50. V square is equal to 50 or implies V is equal to square root of 15 meter. This will be the velocity of the projectile body. So that is what you are asking. Fine. So you have to interrelate this concept of springs with oscillation, of course oscillations with projectile motion. So this kind of questions are called kind of level 3. So you have to remember, you have to apply the other concepts to this concept of oscillations. Collisions with oscillations or projectile motion with oscillations, even friction sometimes with oscillations. Here we are not considering friction. Okay? Here, no friction, smooth surface, no need to apply friction. So, different concepts have been interrelated. Okay? So, how to deal with this, you should have an idea. So, this kind of questions will come in a level 3 or level 4, the higher level questions. Okay? Is it clear? So, similarly, you can also work out question number 18. Question number 18, you write this now. Verse, wait a second. So where maybe one is there. See, next question number 18. Question number 18. How to deal with this kind of questions you can see here. The mass M shown in figure oscillates in simple harmonic motion with amplitude A. The amplitude of the point P is, it is given that there is horizontal surface, and an end of a spring is fixed here, and it is connected to a point here. At this point, another spring is attached, and the free end of is attached to a block. Right. Set. Right. The springs are having spring constants. This is the point P. So again, in reading the question, a mass M, this is a block of mass M, shown in figure, oscillates in simple harmonic motion with amplitude A. The amplitude of the point P is. So let us say we have stretched this little bit to a small distance x. So this end of the spring is stretches, this point displays from here, this end of the spring also displaces. Yes or no? So if it stretches through some distance x, that means the entire system will stretches. This is similar to this one, right? I already discussed this series combination. Yes or no? I am discussing the effective spring constant. What I have discussed, the force mg acts here, same force acts on all both the springs. If you consider the springs are ideal, ask the springs. So same force acts. So if it is having spring constant K1, this K2, as force is same because of different spring constants, different extensions will take place in these two. So if it is pulled through some distance x, so this x is equal to sum of the extensions produced in this. Similarly here, so you can say that extensions produced in each spring x1 plus x2 is equal to, here that is actually you can take it as x or maximum displacement is, you can take it as amplitude. Amplitude is equal to x1 plus x2. That is equation 1 you can take. but as the same force is acting on both the springs, same force that they are having spring constant K1 and K2, as force acting on one is equal to force acting on spring force. So if a force acting in this direction, additional force or spring force acting in the opposite direction, that is Kx. So if for this K1 x1, for this it is K2 x2. You can write from this, because here at this stage you have to simplify this based on the options again, based on the question. So here you can think about what it has to define. The amplitude of point P. Point P means related to this one. So x1 you want. If you want x1, write for x2. So if you write x2 is equal to k1 x1 by k2. From this if you substitute here, the equation 1, what you can write, x1 is x1 only, as x2 you can write as k1 x1 by k2 is equal to a. What is the displacement of P? So whatever the displacement this point is undergoing, this also is attached to this. So it undergoes the same displacement, the point P. So you can say it is x1. So you can write from this x1 by taking out, you can write 1 plus k1 by k2 is equal to a. This one simplifying further, you can write k2 plus k1 by k2. x1 into k2 or k1 plus k2 by k2 is equal to a, or x is equal to k2a by k1 plus k2. This is the displacement of the point P, which is at this edge. Which is at this edge of the spring, at the second edge of the first spring. Is it clear? You can understand you can calculate any required parameters based on this also, some other related terms also. Okay, so have a note of this.